Okay. I will start. So maybe until 10 I think. Okay. Thank you very much for your time so in the early time. So good morning. So I'm Takenori Obo, so from Tokyo Metropolitan University. Okay. So today I talk about the approach for the system development, so related to the rehabilitation. Okay. So in our laboratory, so we apply the robot technology, AI technology to the healthcare and the rehabilitation. So I talk about the part of the work. Okay. First, so this shows the introduction. Uh, so in the system development, so we have to consider the different level of the needs. So for example, prevention, monitoring, and rehabilitation. The need is totally different. So, for example, so for the elderly support and the health promotion, so we apply the communication robots to interact with elderly persons and promote the healthcare exercise and so on. And in the modern system, motion analysis is very important to assess, to evaluate the activity of the daily, yeah, activity in the daily life. And furthermore, in the rehabilitation task, uh, we have to uh, evaluate the detail of the physical and cognitive ability of the patient. Okay, so like this. So in the system development, we have to consider the design of the system. So in our approach, we consider this kind of system design, interaction design, communication design, and experience design. So in the interaction design, we consider the design uh, related to the physical interaction so with the object and the user interface. And in the communication design, we have to consider about the relationship between the human and the robot and object and the environment also to create the space for the healthcare and the rehabilitation. And the last one is experience design. So actually, experience design is the most important in this design. We have to consider the user experience, so related to their motivation and emotion. So if uh, if the patient cannot receive a good impressions from the system, we cannot promote the exercise rehabilitation so by using the system. Okay, so it's user experience is very important. So today, so we talk about so today I talk about the system development based on the this kind of design. Okay. Okay. So to discuss this kind of the system design in our laboratory, we developed the uh, living rubble. So by using a square so like this. So we have implemented some sensors and robots so into the living rubble. So the living rubble is a square type. Therefore, so we can bring the laboratory to the real elderly home and critical facilities. Then, so we can discuss about the needs and seed matching. So by using the real robot and sensors. So the purpose of this Ferreira Living Labo is to provide the opportunity to gain the clear understanding of their capability and limitation in the data, and uh, to grasp their aspiration of what they would like to achieve so in near future. It's very important. So this is the internal, inside of the living level. So yeah, this kind of the this kind of sensors and devices are implemented so into the laboratory. Okay. And also, so I established the open lab also to discuss with the therapists about the new approach for the rehabilitation. So here, so I prepared some devices for the rehabilitation. So like this, and discuss about the new approach. So by using these devices, and uh, we sometimes we have the seminar so with the nursing students. So to uh, ex- to explore the novel approach and uncover the solution for the rehabilitation. Okay, so anyway, so today, so I talk about the rehabilitation support system. So especially, so we focusing on the cognitive rehabilitation. So do you know cognitive rehabilitation? So most of the yeah, students after hearing the rehabilitation, maybe yeah, image physical rehabilitation. But cognitive rehabilitation is very important actually in Japan. So later, so I'll explain the background. In the cognitive rehabilitation, we focus on the cognitive dysfunction. So the purpose is to reinforce and re-establish the previously learned pattern of behavior and establish a new pattern of the cognitive ability and competitive mechanism for impaired neural system. So that is yeah, many type of the cognitive dysfunction. So we have to consider about the various type of the interface and the control. Okay, this is the background so in Japan. So actually, the death rate of the brain growth is degrading so recently. But many patients suffer from the after effects, so like such as cognitive dysfunction. So therefore, the brain growth is one of the major cause for the long-term care. So it's a very big social problem so in Japan. So we have to develop the evaluation system and training also. As I mentioned before, there are many types of the cognitive dysfunction. The symptom is depending on the place of the brain damage. So like this, related language, behavior, such planning, and attention, yeah, face recognition, and so on. So, so especially in my study, so I focus on the attention program here. Uh, Universal Special Needs USA. Okay, I'll explain the details of this function. Okay, The patient with the USM cannot pay attention to the one side. So, but most of the patients have the right side brain damage. Therefore, they cannot pay attention to the right. Okay? The USM occurs in the approximately half of the patients with right side damage. The variations of the symptom is different. Very various. The symptom is very various. The symptom is different from the patient to patient. For example, uh, egocentric brain and allocentric brain. Some patients cannot pay attention to the whole of the thing, so half of things, so like this. But others cannot pay attention to the half of the object, so like this one. And the attention is not only related to the visual function. It's related to multimodal function. Therefore, some patients cannot pay attention to body image. So it's very difficult for the therapist to evaluate and assess this symptom. So yeah, there are of the assessment test. So actually, for the patient, it's difficult to adjust the reference frame. So reference frame to the real environment. Also, in this application, we there implement the way to expand, move, and shrink the reference frame. So reference frame means the touching area. Yeah. So like this. Okay, I'll show the video. Yeah. We can. So here, the reference frame is represented by the target. So candidate of the target. So like this. The uh, the frame can be expand and move. So by using the appearance pattern of the target. So like this. If the patient has a USN, they cannot aware the appearance pattern. So we consider this kind of the task is used for the detect the future more details. So I skip this one so because of time. Yeah. From the so I have talked about the our system development of the USN. So by using the immersive real system. So in the many related work, recently immersive real system has been applied to the rehabilitation tasks and assessment. Yeah, so similar to our works. But we have the common challenges. So to apply the AI robot technology for the rehabilitation and immersive VR system also. So first one is we have to promote the patient PDCA. So uh, we have to improve the motivation. So for the rehabilitation. So we have to develop the support system toward the human potential and enable measurement, evaluation, and training. Okay? And second, so we have to consider knowledge extraction, not only provide the rehabilitation application, rehabilitation support system, So we have to consider the knowledge extraction. So here we have to extract the formalized knowledge so from the service. And the knowledge can be applied to the practice. Yeah. So and uh, this kind of the knowledge can be used for the generating the new know-how also, new approach also. So we have to create this kind of we have to create the platform so to realize this kind of the cyclic process. Okay. And furthermore, so we have to consider user modeling. So to obtain the knowledge, user modeling is very important. Therefore, we have to consider modeling of the human, physical, cognitive, and experience aspect so through the modeling system and the AI technology. Okay. To discuss this about this kind of the challenges, so we also propose the concept of the platform for the compensation system rehabilitation. Here, so this shows the process of the rehabilitation task. So left one is related to user modeling. Right one is related to the practice and the application in the real environment. So in the user modeling process, uh, the user modeling process, the purpose is to extract the knowledge so from the patient. So by using the big data, and so yeah, like this. And by using this knowledge, we can update the rehabilitation approach. Then new know-how is created in the practice. Okay, this kind of cyclic process is very important, but it's difficult for the therapist uh, to promote this kind of cyclic process by themselves. And also, machine learning and robot technology, this kind of the engineering approach is very important. Okay? So in this framework, the purpose is to encourage the continuous emergence of the knowledge and the practical application. Okay. Sorry. Okay. Okay. Today, so I show the examples of the, our system development. So related to this concept. Okay. So first, so this shows approach for the future extraction of the patient. So in our approach, we use the topological mapping. So to extract the cognitive and physical future of the patient. Maybe some students know the unsupervised learning approach, maybe. So, no, I'm not sure. So, 3 degree, the bachelor student, right? Most of yeah. Mm. If you study the machine learning approach, maybe you know the unsupervised learning approach. So, self-organized math and so on. Uh, in the topological mapping, we can create a topological map, so like this one, so by using node and edges. So the most famous approach is the self-organizing map. But in case of self-organizing map, the learning algorithm not include the node deletion algorithm. There was also unnecessary node and edges are created so by using so like this. But in our approach, we use the GNG. So the running algorithm includes the node addition and node deletion algorithm. So therefore, the topological map can adjust the topological structure to the data distribution. Sorry. So we use this topological mapping approach to extract the behavior future. So for example, so this shows the data distribution of the code. Then, so we can extract the data points so like this. So here we can reduce the data points by using a topological map and structurize the each data point. So by using the edge and node. And furthermore, so I implement the temporal running process so into the topological mapping. So by using the spike response model. So today I'll skip the detail of the explanation of the this model. But if the if we implement the this temporal running process, then the topological structure has a spatial temporal pattern on the topological structure. Okay, this shows the overview of the topological mapping. Sorry, our approach. So in our approach, so topological mapping and temporal coding is both are implemented. The process are conducted alternately. So right. So therefore, from this result, we can estimate the movement pattern so of the gauge. So by using from the current position of the gauge point. But usually, the gauge prediction is also depending on the strategy of the patient. This sorry, this means patient can obtain the strategy for searching the target sometimes. So related depending on of the their experience of the touching a target. For example, okay.
So Obo sensei,
Yeah.
this is similar the reinforcement learning.
Yes.
So S is state,
Yeah.
A is action,
Yes.
R is reward.
Yeah.
So I think this is important for our future cooperative research project because in the class just discussed with the now sensei because we propose the content attention ontology. So this is attention direction.
Yeah.
So I explain in Chinese.
Yeah.
我说明一下，就是刚刚在车上，因为我们等一下会有一个揭牌仪式，公共电视台会来采访，就是我们跟日本要成立一个联合实验室，就我们台南大学执行教育部的高教深耕计划。那成立联合实验室就是自然沟通智慧跟机器人。我往前老师做机器人做3日本的机器人，我现在做很好的是中国大陆。可是我说为什么日本不做？因为太贵，买不起。那个机器人，你看它会打拳击，你看到中国大陆不是很多机器人，这些机器人，可是未来可以用来照顾老年人，比如老师慢慢变老了，退休了以后，那照顾，那这边就会，你看这边很多数学公式，那等一下老师也会讲因为我们这一个经费是 HPOE 国际电机电子科技学会跟阳明交大出的，所以等一下大家都会拿到一个面包餐盒，那个钱是阳明交大，当然我先垫了，那最后阳明交大钱要还给我。好，那他这边讲的就是那个 attention， 那我们讲的就是引导什么呢？就增强式学习或强化学习。所以你看看 S 就是 state，A 就是 attention， 那 R 就是 reward。比如说我们昨天老师昨天早上上课，然后中午我们朝鲜就跟我去中大国际会议厅，我们有一个成果发表，第一个是那个清华大学资工系的教授，现在是那个南海的校长，关系。第二个 第二个就是那个台大李宇中老师，就是我们软体工程用的。那第三个就是我们旁边是台科大，接下来
全部台新交材，那结果我们得到费用，我们就会得到费用啊。就我们的成果是完成台新交材，那中央中心那这个会减掉。这我们就那个你改天那个我说他就知道。那当然也是学长他们表现很好。那我们最主要就是要做这一个 attention 就是这边的 ontology 跟 raw 法全部都结合在一起。那这个就是我们未来我们学校要做的一个方向。11点的时候我们要到实验室外投币学习下去，我们在那边做一个接排仪式。然后12点的时候我们到普通校区和校长、国际长、研发长有限的做在那接排。那表示说大家念台南大学也不错，现在在考研究所嘛。那所以那个考研究所时间快到了。对，因为这边就是 attention。那等一下我也会讲，我讲的时候就不会讲这些数学公式，我就讲开进去。那个包括周华老师可能讲比较基础的。那个 Obo 老师他讲的就是比较这边讲多的一些数学。那当然，如果对数学有兴趣，你就可以去研究这比如说这边你看基本的数学公式。那如果对数学没有兴趣，多应用也很好。这个就是大家接下来都是算是年级要念就懂了。好 ，So I just explain later. I will explain the content attention for the robot. So later. I will invite you and now to the first floor and we will put photos together. Okay, thank you. Okay. He may explain everything. Okay. Yeah, here, so yeah, this, sorry. This indicates the model of the strategy for searching the target. So if the prediction is correct, so to touch the target, then the reward is provided in the model. Therefore, so the strategy is updated so in this model. By using this strategy and temporal relationship, spatial temporal pattern, so we can obtain, we can estimate the gaze movement so from the current position. Okay. And after estimating the gaze position, so we can also estimate the attention area. So by using the gaze distribution, so like the attention map. So, but this is a very simple model. So therefore, so it's may not reflect the human attention area so perfectly. Okay. But yeah, here we use the data distribution, so like this, to detect the target, so like this one. Yeah. So if the target is appears on the attention area, the model, patient model can detect the target, position. So the so by implementing this model, so we can simulate the patient movement. So like this in the virtual space. Okay, this shows the patient simulation. Okay, the patient model can detect the target. By using the attention area, so like this one. Yeah, but in this case, the attention area is depending on the just simple gaze distribution. But in case of the patient, some patients may have this kind of the attention area. Therefore, in our patient model, we applied this this kind of the map. So distribution of the to represent the attention area. So half of the that distribution. Okay, I show the example. Okay, first, so yeah, I show the example. So first, this shows the yeah. So typical US patient. Uh, so in this case, the patient cannot pay attention to the left side. So simply so like this one. So the patient only pay attention to the right side. So clearly, so like this one. Therefore, so data distribution also like this. So from this, by using this data, I created the simulation. So like this. This is not a real data simulation. So from this result, we can also obtain the response time so from the simulation. So like this. Of course, the body structure is totally different of from the real patient. Therefore, therefore, there are difference so between the response about difference of the response time so between the real and patient model. Okay, but the future is similar. So the patient model also has a delay so to react the left side target. So like this. And this shows another case I mentioned before as right right type USA. So in this case, the patient has a strategy. So like this, they focus on the left side edge of the table. So like this. So the phrase is used for the starting point of the for the starting. So we create the simulations also by using this data. But actually, so in this case, the result is not similar to the real patient. In case of a real patient, the time is more improved. So on the left side, but on the other hand, uh, for the right side target, the time is longer than the yeah beginning of the time. But in case of the US model, the result is similar to the first one. The model cannot pay attention, just neglect the side, left side. So therefore, so after this result, so we discussed about this hypothesis that patient has compensated strategy. Okay, therefore, we tune the parameter, model parameter. We can adjust this part, reward part. So if the reward so if we increase the reward for the target appearing from the left side, then how then the maybe the patient behavior can be changed. So we check. Then so we can get this kind of result. So this result is similar to the similar future has a similar future of the to the real patient. First, the reaction time is longer. So long reaction time is obtained. So in the past beginning of the task, but after that the time is improved also. So in the model. Okay? But on the other hand, on the right side, the time is longer on the end of the term. Okay? So from this result, uh, this result, we can discuss the patient has a potentially has a USN, but uh, yeah, yeah, okay. Because next time will be okay. Yeah. Next slide fine. Yeah. Okay, wait. Yeah. From this result, we can uh discuss So the patient potentially has a USM. Yeah. So they use strategy of this kind of strategy. Yeah. We can discuss from the simulation and model. Okay, finalize the presentation. Yeah, this is the conclusion. So in this presentation, I introduced our approach of the system development of related to the rehabilitation. So here, we explain the concept of the computation system rehabilitation. The purpose of the concept is to encourage the continuous emergence of knowledge and practical application. To discuss about that, we also consider these kind of the aspects. So PDCA promotion, knowledge extraction, user modeling. So to discuss about that, I showed example of the system development for USN assessment. Okay. In the future work, we try to develop the robotic rehabilitation chair, so with the MRT real system, so like this one, and we also implement the cognitive model so into the patient robot, so like this one. So to discuss about the rehabilitation approach in the real environment. Okay, okay, that's all. Thank you very much for your attention.